my name's Dave Napton. I'm Principal Lecturer for Engineering at the University of Sunderland. I teach across all of the undergraduate programmes, and today I want to talk about how those programmes are structured, what you will experience when you're studying those programmes, and how our programmes fit into the wider industrial context. Engineering is based at the Sir Tom Cowie campus in Sunderland. It hasn't always looked like this, however. It's not that long ago that Sunderland was at the absolute heart of the Industrial Revolution, building ships, other things that were happening very close to the university across the northeast. There's been some amazing inventions. Invention of steam trains, hydroelectric power, the electric turbine, even claims to the light bulb. Devices that have changed and revolutionised the world and the way that people live today. Engineering has changed somewhat though. Many of those industries are no longer with us, but there's a new breed of engineering. There's been other industrial revolutions. We've been through automation, where the people actually putting those products together have been removed in favour of robots and automated systems, but it's still engineers that make that happen. What we can see in this slide is advanced manufacturing and what modern day manufacturing might look like. This is a facility to manufacture toothpaste, a non-technology product, something that we don't think of as being engineered, but how the raw materials and how all the different components, the packaging, the tubes, the caps and everything is brought together, assembled into a product that we like to buy and we like to use, and then distributed around the world. It's engineers that make all of that happen. So there are some exciting jobs in very, very high tech, clean environments. Myself and the rest of the team, we've all worked in engineering and applied research projects, and we will all say it's a rewarding, yes, challenging at times, but it's a rewarding and a fruitful career that brings many, many of opportunities. So what have we done at the university in response to these changes in industry? Here are some of the facilities. We have dedicated laboratories to different areas of the curriculum where we conduct our research as well. We can see students working in an interactive way. Yes, we have lectures, but there are lots of opportunities across the programmes to put the theory that you learn in the lectures into practice in the laboratories. And this results in a very, very interactive learning experience for students. You'll be working in large groups, small groups, and in lots of different ways across the curriculum. We also have facilities at the Industry Centre, and this is where the university runs specific projects which engage with industry. So there's industry level specification kit that we have access to as well. And where there's overlap between these projects and the curriculum, the staff are involved in developing the content and also delivering some of it as well. So why study engineering? There are lots of reasons. At the moment, the United Kingdom is approximately 20,000 engineers degree qualified short every year, and that's to replace staff which are leaving the sector due to an ageing workforce and leaving due to retirement, and also for the UK to reach its economic potential. Those jobs are also good jobs. They're well paid. They're above the national average for salaries, even as a graduate. So you can get some good jobs and some well paid jobs. But I think there's more to that as well. Engineers have a social responsibility and a moral responsibility. I'm not for one moment saying that engineers over the years haven't contributed to some of the world problems, but I do firmly believe that it's engineers working with professionals from other sectors as well that will be well placed to solve many of these world problems. The programmes we offer at undergraduate level are Bachelor of Engineering in Automotive Engineering, Bachelor of Engineering and Master of Engineering at Mechanical Engineering, also Electronic and Electrical Engineering, and also Manufacturing Engineering. The Bachelor of Engineering programmes are all accredited by the IET, the Institution of Engineering and Technology, and on completion this is partial satisfaction for moving your career on and becoming a chartered engineer and being able to fast track that process. Many of our students stay with us as well to study a Master of Science after the Bachelor of Engineering. So if it was engineering or project management, manufacturing engineering, mechanical, electronic engineering or advanced maintenance engineering, these are all programs we offer if you wanted to take your studies further. Some of those students even stay on and do a PhD as well. Doesn't matter which of those streams of engineering at undergrad that you join, all of those engineering programs will follow a common first year. This is really, really useful for a number of reasons. Firstly, you will leave upon successful graduation, you will leave with a broad engineering skill base as well. So even a mechanical engineer will have done some electrical engineering and vice versa. And this is really important for two reasons. Number one, employers really look for that because you will be working as a multi-skilled engineer in a multifunctional team as well. So you'll be working with engineers and other professionals from other disciplines across any organisation when you're working on projects. Also, if you're slightly uncertain at the moment, whether you're not sure if it's mechanical engineering or automotive engineering or electrical engineering, for example, that is for you, you can study the first year, and if some of the content that you come across in that first year maybe changes your mind, there's the opportunity to change there into the second year as well. Talking about the second year, that's when a lot of the technical content comes in. Your chances are you'll be working in smaller groups then as well, and you'll be specialising into specific engineering fields which are related to the title of the programme that you're studying. Every programme has the opportunity for students to undertake a placement year. This is an extra year of study which goes between years 2 and 3, and it turns a 3-year programme into a 4-year programme. But these are generally paid, and it gives a student valuable experience in the world of work. You get a chance to put 2 years worth of study into practice and drawing on experience from other areas of your life if you've been involved in any volunteering work and things as well. And it's a brilliant case study where you can see engineering taking place every day, and then you can bring that back into your final year, maybe bring a project back as well. Because companies are typically paying students, recruitment is competitive, so the university will give you lots of support in preparing your CV and presenting yourself at assessment centres and in interviews and things. But it's very much an assessed part of the programme as well, and I think students and companies get an awful lot out of this experience. Often, students impress companies so much that the company is willing to offer them a job for after graduation, but it's much more than that. It's about that. It's about the experience. It's about seeing engineering in practice as well. Here we can see Joe Butler, who's currently just returning. He's been on placement with Bosch Engineering, and he says that his placement was a life-changing experience. He's been able to use those tools and skills, and he can see how he can now put those into practice for a fruitful career in engineering. Whether you go straight on into year 3 or whether you do a placement and then come back, year 3, I always describe it as a year of 2 halves. You can see from the slide there that 3 of the modules that you study are common across all engineering disciplines. You will undertake a project. I'm going to talk a little bit more about that in a moment. But things like manufacturing systems design and professional engineering management techniques are very important. It's one of the things that the IET, when doing the accreditation, look for, and it's one of those things that take your skills and knowledge to the next level, recognising that many of our graduates will work in managerial positions, they'll be leading teams, and that gives them some of those engineering ethics and project management and things, those skills that they'll need. There's also 2 modules in there which are directly related to your discipline of engineering, and they give you the technical skills to be working as a highly competent engineer at that level. The project is a large part of the final year. It's a feature of all of the programmes. You hear people talk about dissertations at university. We actually do a project because there's a practical element to that generally, and it gives you a chance to apply the knowledge and the skills that you've learnt across the entire programme. Many students explore in greater depth one of the areas that they've perhaps really enjoyed throughout the programme, or it's an area that they really want to work on in the future. Project themes might be the design of a component or an artifact. It might be looking at an engineering process, or it might be looking at material science. It's very broad to encompass engineering in the wider sense. There's some examples there in the pictures. The top picture there is an impact attenuator from our Formula student car, and you can see that on the test bed being squashed and deformed as part of the testing which actually took place at the end of the project. The next picture down is a small rig built in the labs. It's a small conveyor system, and it's small scale, but it's very typical of the sort of engineering project you might find in manufacturing engineering. At the bottom is another design project, and that's actually a robot gripper that was designed and installed in one of the robots in our labs by a student using pneumatics and mechanics and lots of other skills and knowledge there along the way as well. If you're doing the Integrated Masters, there's a 4th year of study, and that year will start with a research module, very much academically focused, and it will finish with a group project. So similar to the previous year study, but this time you're working in a group, working with engineers across different disciplines, just like you would be in industry. Some great employability skills that you'll pick up there, drawing your knowledge from across all years. make your contribution yourself, of course, but then, you know, working with other engineers and colleagues on the programme. The modules in the middle are very much technically focused again, which are very pertinent to your programme of study and the title that brings. But these modules, yes, they're technically focused, but they're very industry aligned as well. Lots of problem-based learning and case studies and examples from real industrial applications. Last year's graduating cohort offered some really positive feedback in the National Student Survey. They felt staff were good at explaining things, the course had challenged them to achieve their best work, they'd received appropriate advice and guidance when needed, they felt the course was well organised and that they had opportunity to work with other students. All of these areas and the overall satisfaction all scored above 90%. I'd just like to share some examples and some testimonies from other students and show you what they've moved on to do with their career after studying with us. Here's a picture of Shannon in our electronic lab, and he graduated from electronic and electrical engineering, but he shared that he'd enjoyed loads of aspects of the course, went out and did a placement, really aware of the breadth of the subject. So he was much more aware due to the breadth of the curriculum and where he might want to work and where he might want to pursue his career after that. Beth Harrod graduated in recent years from mechanical engineering. She found the course challenging but very interesting as well. Her advice is to make the most of the time at university because it goes over so quickly. And I think 3 or 4 years when you're starting out can seem like a long time, but will keep you busy and lots of interesting things to do in that time, so it will feel like it goes quickly. Her other advice is also to work very hard and most importantly believe in yourself. I think that's good advice, but she certainly felt that her time at university was a very positive experience. Blaine Huntingdon also did a placement. He graduated from electronic and electrical engineering. He's a graduate engineer now at Hitachi Rail Europe. I always think Blaine's story is quite interesting because when he started his degree, Hitachi weren't building trains in the northeast of England, so it's not a career that he would have necessarily seen himself working in. But he was able to use the technical skills and the transferable skills from his electronic and electrical engineering degree. Yes, he's still an electrical engineer, but that wasn't necessarily training for the rail sector. But he was able to work in that sector, and many of our students go on to other areas which aren't necessarily directly related to the title of the degree, so don't worry about that too much. You know, it can open up opportunities in renewable energies and power generation, marine, defence, and all sorts of things there. Just to kind of go full circle with the presentation, here's an example from Cameron. He went to GlaxoSmithKline on placement and returned there for employment as a graduate engineer as well. This is further example whereby you might not think of the product that GSK turn out as being engineered, but Cameron is part of the team which is responsible for sourcing the machines, making sure all of the machines and the automation does what it's supposed to do and works first time every time within the factory. If you want to see more of the campus, there's a virtual campus tour online, along with more examples such as Cameron, Beth, Blaine, lots of other students there as well. Their stories, their experiences, which are there as part of the case studies. Lots of information on our YouTube channel, social media as well, and of course if you've got any questions that you want to ask on a one-to-one level, please use TAP, the app which you can speak to existing students and staff as well who can answer those questions for you.